So this is post-assignment 1 stuff. So if you're still working on assignment 1 diligently, don't worry about this just quite yet. It's more important for you to get your review done and get going on assignment 1, but some of you will zip through that assignment pretty quickly, so I wanted to make sure you had new material available. So this is chapter 13 in the book, and we'll be discussing something called classes. And if anybody's ever taken a Java class, or I should say a Java course, one of the things that Java has is classes, and C++ has classes as well. C does not. So let's go ahead and talk about what we've been doing up to this point, which has not been dealing with classes. We've been doing a type of programming called procedural programming. And then let's kind of split a line down here. So we've been let's do this. So I make use of different colors. Let's choose a color here. And let's go with this dark green. So okay, so procedural programming. And then let's split it down the middle here. And then we'll talk about classes, and actually the name is what's known as object-oriented programming. And sometimes you just see it written as OO for object-oriented. Okay. So in procedural programming, we have data. We have our ints, strings. We have our structures. And then, so that's our data. And then we also have functions. And hopefully that makes sense. There's a clear distinction between data and functions. So object-oriented programming is actually not that dissimilar. It also has data and functions, except for we kind of do it a little bit differently. So previously, if we had a car, we would create a car struct. And if we wanted to do some operation on that car, we would make a function, and that function would do something. So say we wanted to start the car, and we would make a function called isStarted. Well, object-oriented programming deals with something as known as a class. And what happens is you keep your data and functions all within a class. So what we talk about in object-oriented programming in the object-oriented world, we talk about having members or member variables, and then we have methods. And they're actually almost the exact same. The difference is we put them all into one class. And so just so when I use these terms, you know that they're equivalent. So when I'm talking about data members, I'm talking about basically the same thing here, and then so this is the equivalent over here. So let me scroll down and just know that they're equivalent, but they're just slightly different. So let me scroll down here and actually start to discuss some object-oriented programming. Okay. So say we have a car. Let me just go ahead and do it like this. Well, what we can do is in object-oriented programming is have a car, and if we wanted to make the car go forward, what we do is we, within the car, define a function to make it go forward. Or let's say start the car. So and this may seem a little strange right now, because couldn't we did that before? We did, but we would define a separate function now within the car itself. So imagine if you could somehow magically, in our car struct from earlier, if you could put functions inside that car. And so that's what we've actually done now. We put functions, or what are known as methods, within the car itself. And so we have our car, and then so there's a special syntax for it. So we say my car. And then what we do is, if you remember from before, if we wanted to do something with a, it's probably the easiest way to think about it is being very, very similar to a struct, except for you can put functions in it. So before, if we wanted to do something inside, so say my car, and then we wanted to set some variable and then say call it color. We wanted to make it equal to blue. Okay, so that might be how we modify it before. Well, now what we could actually do is we could make a function called change color, and we'll learn the details about this, but this is how you do it. You do a dot, and so now we're actually able to call a function, and what we want to do is maybe make a function within that called change color, and then we pass it the argument blue. And so what you can see here is this is kind of cool. We couldn't do this with a struct. Before with the structs could only hold data, but with a class with object-oriented programming, we can actually create a class which is very similar to a struct, but it can hold functions, and we have a special name for those functions. And so now we can say my car dot change color, and we've created a function within that. And so we couldn't do that before. That's kind of cool. And what that gives us the ability to do is change data within a class. So if you remember before, we had to jump through all kinds of hoops with pointers and functions, and we don't have to do that anymore, because we can say change the color, and then we give it a color. And now if we did a cout and actually viewed the contents of my car dot color, it would show blue right here. So let's do a comment and say that it's now blue. So that's kind of cool, and that's basically all object-oriented programming is. There's a lot of theory, and people talk about, well, if you Google it, and in this course I won't make you learn too much of the theory behind it, but people have long discussions about object-oriented programming, what it is, but it's very simple. Basically, you're taking something similar to a structure, and you're giving it some extra features, and there are even more features, and we'll get to those eventually. I don't want to confuse you too much, but really that's all a class is you're basically taking something like a structure which could only hold data before, and you're giving what they call behavior. You're actually taking your car, and instead of having to create an external function, you're saying, okay, I want to, within the car, give it functions. And what happens is, because you haven't separated out your functions and your structures, and they're all kind of one thing, you can start modifying through functions, through these what are known as methods. And if you want, you can use the terms interchangeably. But I wanted to make sure, in case anybody Googles this stuff, the technical term is methods, but it's basically a function. It works exactly like a function. But you can modify the car, and you don't have to deal with pointers and all these other things. So it kind of simplifies things a little bit. People do sometimes still create external functions and structs and still program like that. So that's why I wanted you to get used to that. And if you ever work in pure C, that's not C++, which some people do. Some people just use certain parts of C++ and they won't use the object-oriented part. And so you'll understand how that works. But it definitely simplifies things. So instead of having to jump through all the hoops, you can just say, I want to change the color, and you don't have to pass pointers and all kinds of other things around. So that may seem a little strange and may not make a lot of sense right now. Once we get actually into coding and I show you the syntax of how to define a class, it'll make a lot more sense. But no, that's just the general overview of how object-oriented programming and classes work.